The next question is to design finite automata for unary number divisible by 3. So for that, we will first go by the maths method. What is that in the mathematical method is that we have to find out whether the number is divisible by 3 or not. For that, we should know the number system. As we know, the unary numbers are nothing but the occurrences of the number 1. So we had already discussed the decimal number system to unary number system conversion. So let us brief it. So whenever we are having decimal number 1, what will be the corresponding unary number? Unary number system is nothing but here we are having only one symbol for generating the entire number system. For example, I have considered bit 1. This is the symbol which can be used for generating the entire unary number system. Now, if you are having decimal number 1, what will be its corresponding unary number? The corresponding unary number is that occurrences of 1. So for number 1, how many times this symbol is going to repeat? It's going to repeat only once. For number 2 means how many times this bit is going to repeat. So this is going to repeat twice. So this is your number 2. For 3, how many times this bit, your symbol 1 is going to repeat. Symbol 1 is going to be repeated twice. For 4, how many times your symbol is going to repeat? It's going to repeat 4 times. For 5, there will be 5 occurrences of 1. For 6, there will be 6 occurrences of 1. For 7, there will be 7 occurrences of 1. For 8, there will be 8 occurrences of 1. For 9, there will be 9 occurrences of 1. And 10 number we are not considering because we had considered decimal number. Decimal numbers is having the basic units, basic symbols from 0 to 9. That's why we are not going to consider it. Now, in the mathematical method, the second method is to divide the number by your divisor. So here the first number is number 1. We have to divide by 3. So what we can find out, it is not divisible and the generating remainder 1. Second number is 2. When it is by using the unit number system, it is nothing but number 2. It is going to generate remainder 2. Second number is 3, which is the 3 occurrences of 1. It is completely divisible by 3 and generating the remainder as 0. Now the next number is 4. That is the 4 occurrences of 1, but it is divisible by 3. No, it is not divisible by 3. It is generating remainder 1. Next number is number 5, where it is divisible by 3. No, it is not divisible by 3. It is generating the remainder as 2. Now the next number is 6. Whether the 6 is divisible by 3. Yes, it is divisible by 3 with the remainder 0. The next number is 7. The 7, that is 7 occurrences of 1. Whether it is divisible by 3. No, it is not divisible by 3. It is leaving the remainder 1. Now the next number is 8. What is the output of 8 is it is leaving the remainder 2. Now the next number is number 9. What is the output? What is the remainder? Number 9 is having remainder 0. So here all the scenarios here we can find out here having the common remainders. So this situation we can club together. That is the number 1, number 3, number 4 and number 7 are generating what? They are generating remainder 1. Here the scenario is 2, 5 and 8. 2, 5 and 8, they are generating remainder 2. And number 3, 6 and 9, they are generating remainder 0. Now we will go for TCS method. Now what is there in TCS method? That is step 2. In TCS method, as we are having the unary number system which consists of only one symbol. So how many tapes will be there? There will be one tape. Now what is the use of this tape? This is a tape which is open from this side, from the right hand side, containing infinite number of cells. each cell is going to read only single symbol. Here we are going to write the current state, and on reading this input, it will go to the resultant state, and it is going to generate some output here. So output will write on the top. So this is how your tape will look like. As we are having only one symbol here, there will be only one tape. Now we will consider this state, which is ready for the user to input the data. So this condition will give one good name, which is called as QS state. So this is your ready state, or we can say the starting state, which is given a name QS. What input is represented? What kind of input string? Input string is represented by your state, nothing. What kind of output is generated by your QS state? What kind of output? No output till now. Now what we are going to do, as we are going for the unary number system, this is your current position. We are allowed to read one symbol here. What kind of symbol? As we are having what kind of number system we are having? As we are having unary number system, we can take only one bit. What kind of bit it will be? It will be a symbol 1. We will read symbol 1. If we are having symbol 1, that means one string is generated whose name is 1. So what was the output after dividing number 1? After dividing number 1 by 3, after dividing number by 1 by 3, what we are getting, what we got remainder as 1. So what we are going to write here, we are going to write remainder 1 and the remainder 1. This is your remainder 1 situation. So this situation, we can give one good name in TCS, which is called, for example, Q1. So what will be the resultant state? Here we have to write down the resultant state. This is Q1. Okay. So Q1 is the state which is going to represent, which input is going to represent input 1. So this is your input string represented by Q1, and what kind of output is generated? The output generated is remainder 1, that is 1. Now this is your resultant state, and for the next processing, for the next step, this will be considered as the current state. So this is your current state with the tape. So which string is represented by Q1? We have to write here. The string that was represented by Q1 is number 1. And now this bit is already read. Now we are going to move our pointer here to read the next bit. So we are waiting here to read the next bit. The next bit, according to your number system, how many bits? Only one. There is only single bit. There is only single symbol, and that is only symbol 1. So in the next cell, we are going to write bit 1. What kind of bit is, what kind of string is generated here? The string which is generated here is your string 2. So this is your string 2. Now this string 2, what was the output of number 2? The number 2 is what? It is generating remainder 2. So we write here, it is remainder 2. So we will give one good name in TCS, for example, Q2. So what is the resultant state after reading one more bit in Q1 state? The resultant state is Q2. What was the output of Q2 is the remainder 2. So I will write remainder 2 here. Now we will consider this Q2 as a resultant state. Now Q2 is marked as a resultant state. Now which kind of string is represented by Q2? Q2 is representing string 2. We will combine them as one string. So this is 2 occurrence of ones, that is the string 2. Now your pointer will point to the next position, waiting for the next bit. So the next bit is 1. So this is triple occurrence of 1. Triple occurrences of 1 is nothing but your number 3. So whenever we are having number 3, we are generating remainder 0. So we'll write here remainder 0. So remainder 0, we will give one name in TCS method, that is called as Q0. So which string is now represented by Q0 is this string, that is triple occurrences of 1. Triple occurrences of 1. What kind of output generated is 0, and what is the resultant state is Q0. Now this is your resultant state, which is according to your question. What was the question? is that we have to check whether the unary number is divisible by 3, and when the number will be divisible by 3 whenever we are having remainder 0. So Q0 is the state which is producing remainder 0. So we'll mark this as the final state. Okay, now this Q0, which is now final state, will be considered as a current state, Q0 with the next bit. So which kind of string was generated here? The number 3 was generated by Q0. So now this Q0 will be taken together and is waiting for the next bit. The next bit is 1. So Q0, which is 3, when taken with the next bit with 1, will generate number 4. So what was the scenario with the number 4? Number 4 is nothing but you are having output as 1, remainder 1. Whether the condition is already considered here, here this condition is already considered here, and we have given some name as Q1 also. So we write that thing here because Q1 is the state which has generated remainder 1. So this state is already considered. So whenever we are having the string, the state name which is going to repeat here, like state Q1 is repeated here. So that is the end point of designing your tape method. Okay, so what we are going to do now, we are going to, that is the second step of your TCS method. Uh, so this is what you can say the step A of the TCS method. What is the step B of the TCS method? Is that we are going to design state transition table. So we'll write state transition table here. So how we are going to write here? We are going to write input symbol. So what is that input symbol that we consider? That is number 1. And here we are going to write the states. So the state, the first state that we are consider is state QS. So we will write that first. So we write state QS here. Now QS on input 1, where it is going. So QS on input 1, QS on input 1 goes to Q1 state. So QS on input 1 goes to Q1 state. Now next, so this will now become the resultant state we have to write here. So now we are having Q1, the Q1 on 1 where it is going, Q1 on 1. So Q1 on this one generating the resultant state Q2. So we'll write here Q2. Okay, now Q2 will become the resultant state that we have to write here. So Q2 then on 1. So Q2 on 1, where it is going, Q2 on 1 is going to Q0, and which is the final state also. So Q2 on 1 goes to Q0, which is our final state. So this will now become Q0, and here we have to mark the indication of your final state, that is the star. You have to put star in front of your Q0, which is the final state. Now Q0 on 1, where it is going, Q0 on 1, it is going to Q1. So Q0 on 1 is going to Q1. So we have considered all the states which are present in your tape method. Now we will go for the third step of your TCS method, that is designing the state transition diagram. So we'll start with we will represent your state by circle, and the first state that we are going to consider is QS. As QS is your starting state, we will mark that state by putting an arrow. Now QS on 1, where it is going, QS on 1 goes to Q1. So which is the resultant state that we have to draw by putting a circle, name that circle as Q1, and we have to draw an arrow from QS to Q1. So from QS to Q1, we have to draw an arrow and we have to write symbol on it. Okay. Now from Q1, where it is going, from Q1, it is going to Q2. So Q1 on 1 is going to Q2. So Q1 on 1 goes to Q2. So resultant state is Q2 that we have to draw by putting the circle and name it as Q2. And we have to connect them, Q1 to Q2, we have to connect by the symbol 1. Now Q2 on 1. So Q2 on 1, where it is going? It is going to Q0. So Q2 on 1 goes to Q0. And what is Q0 here? We had marked that it is a final state. A final state has to be marked with the help of double circle. Now Q0 on 1, that is going, it is going to Q1. So I will connect Q0 and Q1 with 1. So this is how the diagram is completed. Now the next step of thesis method is cross-checking whether the FA is correct or not. So let us take one string which we have not considered while designing your tape method. So while designing your tape method, we have considered till 4. So now we will take a number, for example, number 5. So number 5 is represented by the 5 occurrences of 1. So now we will start with the QS as this is the initial state. So let us take one bit at a time. QS on 1, where it is going. So QS on 1, it is going to Q1. So QS on 1 reaches to Q1. What is the remaining string? This is your remaining string, 4 occurrences of 1. Now we'll consider Q1 on 1. Q1 on 1 goes to Q2. What is remaining string is triple occurrences of 1. So triple occurrences of 1. Now we'll take one bit, one symbol, and Q2 on 1 goes to Q0. What is remaining is double occurrences of 1. Now Q0 on 1, where it is going? Q0 on 1 goes to Q1, and what is remaining here is bit number 1. Okay, now Q1 on 1 from the table. So Q1 on 1 goes to Q2. So we have reached to Q2. That means whenever you are going to reach your result endpoint as a non-final state. So non-final state represent your string is rejected. Okay, what is this Q2? Q2 represents remainder 2. So here we are having Q2 represent remainder 2. So this is your string is rejected by your FA. Now let us take one more string for number 6. We'll start with QS. Now QS with 1. QS with 1, that is going QS with 1 reaches to Q1. Okay, from the diagram. So QS on 1, QS on 1 goes to Q1. So now remaining string is 5 occurrences of 1. Now Q1 on 1 goes to Q2. So Q1 on 1 reaches to Q2. What is the remaining string is 4 occurrences of 1. Now Q2 on 1. So where it is going? Q2 on 1. Q2 on 1 goes to Q0. So we'll write Q0 here. Okay, what is the remaining string is 3 occurrences of 1. Now the next is we are going to consider Q0 with 1. Q0 with 1, where it is going? It is going to Q1 state. So we got Q1 state. Now we are having remaining 2 bits. Now Q1 on 1. Q1 on 1 is goes to Q2. And then Q2 on 1 reaches to Q0, which is our final state. So whenever we are ending our solution with the final state, that means your string is accepted by your DFA. Now, if you are going to consider the 6 occurrences of 1 is nothing but decimal number 6. What was the case with the decimal number 6 is it was completely divisible by 3. That means this has to be accepted by your finite automata, which we already got. So this is how we have designed finite automata for unary number divisible by 3.